The computers that you use at school are almost certainly connected as a local area network, or LAN. Let's have a look at how school networks have evolved in the UK. In the early 80s, back when Michael Jackson released his single Thriller, my school got its first computer, the Commodore PET. It's an all-in-one personal computer. You've got a monochrome screen, a keyboard, and the computer's inside. They must have blown their budget on it because they couldn't afford a tape drive, and schools couldn't afford disk drives at that time. And the school only had this one computer, and so it couldn't be networked to anything else. A computer that isn't connected to a network is called a standalone. A year later, and I'm at high school studying computer science. Here's a picture of me posing for a photo with another standalone computer, the SWTPC 6800, which had been donated by a local business. In the background, you'll see the BBC microcomputers that we use for our GCSE course. So here is a BBC Micro Model B with its monitor and a floppy disk drive. I remember when my school first got a room full of these, 15 Beebs, but initially only the teacher's computer had the disk drive. This meant no one else but the teacher could save their work. The solution was Ethernet, an economical network system that used these cheap 5-pin leads, some connection boxes, and a clock signal generator. Socket boxes and cable were installed along the wall. This was called the network backbone. Then each BBC computer would be hooked up to the backbone. This is known as a bus topology. It doesn't need that much cable, very economical, hence the name Ethernet. Unfortunately, this one doesn't come with a network port. For networking, they all need something called a network interface controller, or NIC. This could be bought as a kit and the components soldered onto the main board. Each computer on a network is called a workstation, and it needs a unique identifier so that specific stations can talk to each other. On the Beebs, you had to physically set an Ethernet station number in binary by adding or removing jumpers. This one has the jumper in the middle missing, so the binary address of this station is 11110111, so that makes it Ethernet station 247. We call this a physical address or a hardware address. Here's another one with a physical address 100000001, which would be Ethernet station 129. Once each station has its own station number, you would then boot up the file server, the one with the disk drive, and run the file server software. You can limit how many files each user can store, then make a folder or directory for each user. Directory A for the student on station 1, directory B for the next one, and so on. Okay, that'll do for now. So, a student sitting at station 1 could ask for a catalogue of their files, which are in directory A, and load their work. Another student sitting at station 2 would have access to folder B. The students sitting at their stations are called the clients, and so the whole thing is known as the client-server model of networking. Fantastic! Only one disk drive in the room, but everyone can use it to save their work. Since all of the messages to and from the server were sent across the whole of the common backbone, every computer would see messages for all of the other stations, but each station would ignore any messages which didn't begin with its Ethernet station number. With this setup, you could sit at your station in the room and get access to your directory from the disk drive of the file server. You had to sit in the same place every lesson though, if you wanted access to the same directory. In my second year at high school, we got an upgrade to Ethernet file server level 2. This meant that you could sit anywhere and tell the station who you were, and it would provide you with your own directory. I would just type *IAM T-Atten, and there are my programs. For security, you could add a password. Just type *pass. A few years later, when I qualified as a teacher, I got a job in a school with hundreds of BBC's and Acorn Archimedes machines around the school. Things had gotten really slow, even with a fast hard drive on the file server. The network was congested, just like a traffic jam, with too many computers trying to send and receive over the same backbone. Even worse, occasionally there would be a break in a link from one room to another, and the whole network would go down. This took hours of investigating to find where the problem was. The second school that I taught in had some RM Nimbus machines that were also connected in a bus topology, but this one was called Ethernet. They were networked using coaxial cable with these BNC connectors that would just twist together. It was pretty easy to set up, and you didn't need much cable because you were only joining each workstation to its neighbour. Just add another T-piece to hook up an extra machine. The network interfaces for each computer were installed on these expansion cards. So NIC can stand for Network Interface Controller or Network Interface Card. The cards were slotted into the motherboards of each machine. And once again, each network interface controller has a unique physical address. These were big 48-bit numbers called MAC addresses. The coaxial cable provided a good signal with little interference, and the network interfaces could send and receive data at a much faster rate than Ethernet. The rate at which bits of data can be sent along a network is called bandwidth and is measured in bits per second. Unfortunately, due to the bus topology, the network got painfully slow when busy. This is the problem with bus networks. They suffer from collisions. That's when more than one machine sends a frame of data at the same time as another one. If that happens, the machines have to wait and then try again. They soon upgraded to some shiny new Intel Pentium PCs. The PCs were also fitted with network interface cards, but these were for a new type of cable, Cat5 twisted pair cable, and it had different connectors and a different topology, the star topology. This has become the most common way to set up a wired local area network. Each device is connected to a central network device, like a hub. The cables plug in with a satisfying click. The hub at the centre of the topology was actually in the corner of the room, but the topology of a network is just about how the network nodes are linked. One immediate advantage of this topology was that if any cable was unplugged or damaged, it would only affect just that one machine. All the others would be fine. As long as there were enough ports, adding a new machine would just involve running a new cable from the hub to the new PC's network interface card. I think we had 16 computers and a printer, so this 24-port hub was more than enough. The biggest performance improvement came when we replaced the hubs with switches. This is a small 8-port switch, but classrooms had the bigger ones that look similar to the hub. So what made the switch faster than a hub? Well, hubs just receive data frames and repeat them out to all the other ports. It was up to the network interface cards to ignore any frames that didn't match their unique physical address. So, if two machines send at the same time, you still get a collision, just like with the bus topology. The switch is more intelligent. An embedded computer inside the switch would look at the incoming data frames, read the physical address, the MAC address, and decide which cable it should send the data frame onto. None of the other machines would be sent anything, and there would be no collisions. The worst that could happen is if lots of machines sent data to the same one, and you might get some drop frames. This is what the switches look like with the Ethernet cables plugged in. A few of the longer connections to computers at the other end of the school were upgraded to use the expensive fibre optic cabling. Compared to wired cables, fibre optic cables provide a higher bandwidth and can transmit data over longer distances. At this point, it's a good idea to have a go at building a network. First of all, get some equipment. You'll need cable, tools, hubs or switches, and a few computers. Then you need to make and test your cables. Have a go at building a star network. Investigate IP and MAC addresses. Send packets to each other. Get a web page from a web server. Look at the raw contents of the packet and the addresses and the protocols inside. If you haven't got enough equipment, you can book a computer teacher networking workshop at your school on my website www.computerteacher.co.uk. In my next video, Networking Part 2, we look at wireless networking, WANs, and how the whole system of packet switching is categorized into network layers.